Good morning, everyone. Welcome to the annual PhD Open House for prospective students. My name is Christina Burton. I am the Associate Director of Graduate Admissions Operations here at Penn Engineering. We're happy that you're joining us to take a look at what our doctoral programs can offer you when you consider your next steps after undergraduate. So today I will be your host. I ask that you all please mute your microphones, but we would love to see your faces, so please show your video. We will be recording this session, just so you're aware, and we will direct you after the morning session to go on to your departmental activities. You should have received the links via email.
It's a great pleasure to see everyone today, and apologize for our technical glitch. Very briefly, to introduce myself, I'm the Associate Dean for the graduate programs, and I oversee all of our PhD programs across all 6 departments, as well as our master's programs. And I'm also a computer science faculty member with a secondary appointment in electrical and systems engineering. I'd like to start off by saying I'm so thrilled to see such a large number of you come here today, and very happy that you are interested in Penn Engineering graduate programs. And hopefully today we can tell you all the exciting things that we have been doing. So I'm going to do a screen share, and please let me know if you are able to see my screen. Is this looking fine to all of you? Okay, wonderful. All right, so today I'm going to talk about finding solutions to today's and also tomorrow's problems. And we didn't get a chance to watch Dean Vijay's videos, but I always like to remember what he said about we are really here to invent the future, and Penn Engineering is really at the forefront for a lot of really exciting work. And so today I like to put on 2 hats. I'll first start off by putting on my professor hat and tell you a little bit about the research that I do and with some of my colleagues. And then I'm going to segue into work that is related to how Penn Engineering has been tackling issues and challenges with respect to COVID-19, and hopefully gives you a good idea of the things that we do. All right, so very briefly, I lead the netdb.cis.upenn.edu website. And this is a research team that works at the intersection of computer networks and databases. We work with many different faculty members. And before this meeting, I thought, what is the one slide that I could use to really showcase what I really love about Penn Engineering? And so I thought I will showcase these 2 projects. Now, many years ago, I was in a similar situation, as in I was deciding between which place to go to kind of launch the next stage of my career. And one of the things that really appealed to me about Penn Engineering is not only the welcoming environment, but also the fact that we have a lot of faculty members that collaborate across different disciplines. And here I'd like to showcase 2 examples. The first is a project that I have, which is a collaboration between myself and our electrical and systems engineering department. This is a project called flightplan.cis.upenn.edu. And you can actually learn more about this. If you go on the website, there's some really cool demonstration. Now, some of you may have heard about this thing called FPGA, which is a kind of specialized hardware that could be used to program kind of, so unlike say like an Intel chip, which is already pre-built, you can actually program new circuits on these boards. One of my colleagues in the ESE department, Professor Andre Depon, he's a world-leading expert in FPGAs. So about 2 years ago, we got together and say, hey, wouldn't it be nice if we could find some ways to kind of deploy these FPGAs in the data centers so we could use these to boost performance of network switching, right? And today, in data centers, you need to send around tons of data from one machine to another. And oftentimes, the switching capability in the data center becomes a bottleneck. So without going into too much details, we deploy these FPGAs next to programmable switches. And this is actually one of our test beds in our lab. And we've used this as a way to dynamically boost the performance of different network functionalities so that we could get high performance and high levels of reliability. Now, you may be wondering why we call this flight plan. So in effect, the way this thing works is we construct what's pretty much, like a plan. Let's say I'm trying to fly from here to California and I decide, hey, I should go to Chicago and then I should, catch another flight at Phoenix and so on. So our system allows you to write a program in the form of like a plan, and then we give it to a smart compiler that will actually generate the implementation on the FPGA boards and servers. So this is a kind of project that I think showcase the best of Penn, right? We have a lot of software innovations on compilers, on high performance software, but we have to get it working on actual hardware, actual circuits, and showcase the collaboration between faculty across different departments. On the bottom right here is another project which is called DDoS, DEDOS. This is actually a project that I have with two other of my colleagues in computer science in the areas of denial of service detection and mitigation. Now today, one of the ways in which you could bring down a web server is where you have attackers or botnets flooding the server, right? And actually defending against these attacks is very, very challenging. And attackers became smarter and smarter over time, where they could even stealthy, low volume attacks that's enough to give you trouble, but not enough for you to find out where they are from. So in collaboration with faculty working in cybersecurity and programming languages, we came out with a really neat idea where we could automatically break up a software into tiny pieces. So for example, here, even if the attacker were to launch an attack on, say, the C component in your software, we're able to disperse and spread out the attack over a large number of machines and kind of mitigate the effects of the attack. Now, this project is very much right on my mind because on just two days ago, we had this demo to the Department of Defense, and we were able to showcase these through all kinds of attacks, and our system was able to defend against a large number of them. Cool. So with that said about my own work, I'd like to segue a bit to talk about all the exciting stuff that's happening at Penn with respect to COVID-19, which pandemic, which as we all know, has been very challenging for us all. But one thing you also know is that in times of crisis, you can really see the best of individuals and a lot of unsung heroes that came out. And I just want to showcase some of the efforts that we have done within the engineering school, led by PhD students and faculty members. Now, I have to confess, I don't work in the area of healthcare, so I'm able to give you a high-level overview, hopefully enough of appreciation of what we do. So the first is, as all of you know, N95 mask is very effective against COVID, but it's also, particularly a couple of months ago, it was in short supply. So what some of our faculty members in the engineering school, they developed the right kinds of material that allow re-sterilization of N95 mask. And this is in collaboration with the medical school. So you could actually reuse this mask, and each time they are able to essentially do 99% viral inactivation. So you could reuse the mask the next time. And this won the Clinton Global Initiatives grant and was featured a couple of places and has been achieved, kind of attracted interest across the world as well. The next one is actually kind of closer a bit to my research area. This is in the area of differential privacy. Now, Penn has been at the forefront of research that intersects computer science, social networking, and business analytics. And in fact, today you're going to hear from one of the very best, which is Professor Duncan Watts, who is one of our PIK. It's actually a special category of professor hired at Penn that span multiple different schools, right? In the case of Dr. Watts, it's Annenberg, uh, Wharton Business School and Engineering School. But here we have here a COVID-19 problem that we want to be able to tackle through the lens of privacy preservation. Now, one of the big things that we know is we need to do better contact tracing. But contact tracing oftentimes come at the expense of privacy, right? And it's often a very difficult tension. We have some countries taking a very extreme position that will trace individuals wherever they go. But there are also other countries which is very careful about kind of protecting user privacy. Now at Penn, we have been one of the leaders in this area called differential privacy. So what differential privacy say is that I want to publish some private data out to the world, but how could I add some noise or kind of fuzziness to the data such that the data that I publish is still statistically meaningful so that people could actually use it to do their own analysis, but it protects the individual privacy of individual persons' records. So this has clearly a lot of use in the medical domain. And very recently, our faculty at the Warren Center have been using this approach to do better privacy preserving contact tracing. Um, the next thing I want to talk about is actually work which is not only scientific innovation, but also significant social impact. Right at the beginning of COVID-19, when the whole engineering school was scrambling towards moving classes online, and I'm sure many of you taking classes in whatever university you are would have experienced the same, scramble to online. We have a team of unsung heroes in the engineering school that quickly got together to come up with innovative solutions. So on the left here is a slide that shows faculty in our GRAPS robotics lab. And what they quickly realized was because of how contagious COVID was, we need better way to do telemedicine. So what they did was they got hold of state-of-the-art cameras and rechargeable batteries, and they integrate this into a telemedicine card, which our doctors in the medical school can use with appropriate social distancing, so you could allow doctors to diagnose without significantly exposing themselves. Now, while they were working on this, we had about 300 volunteers. Many of them were PhD students that got together to make 15,000 face shields for the Penn Hospital. And that itself, according to Professor Mark Yim, who led the effort, was a tremendous amount of creativity and dedication that went into. And hopefully some of you, when you come to Penn, you can ask him about all of the nice war stories there. And at the same time, we have Professor Xu Yang, who's in the material science and engineering department. One of the problems that she quickly realized with all the N95 and even all of the DIY home mask and so on, is that many of them are not really custom fit to individuals. And while you could kind of build individual masks for every person, it's going to be a huge undertaking. So what she did, and the research team did, was she kind of made use of some of her research in this area, which is called origami-based approach, using special materials. And what she designed was a face mask that could seal very tightly around the mouth and the nose, such that you could custom it at very low cost. And what I learned just recently is that she managed to deploy delivered 10,000 of these masks to Penn Medicine. And right now she's working with the Penn Dental Medicine, our dentist at over there, to utilize 3D printing approaches so you could build this mask at large quantity and at low price. And again, these are things that came out at the height of the pandemic, and I thought really showcase the best of Penn Engineering, where we were able to very quickly pivot our engineering know-how to try to solve pressing problems caused by the pandemic. All right, so I would like to end with one last slide, which is about community building, right? And this has nothing to do with research and innovation, but I thought it's important for us to discuss this as well. One of the things that happened during the pandemic is that students had to isolate, quarantine, and work from home. And at some later stages, we were able to allow some students who needed physical lab facilities to come back. But even then, it was in a socially distanced manner. But at the top of our concern was to ensure that our doctoral students are well and supported, right? So I always tell people that my own students, they're almost like my own kids, right? They're not here just as our employees to do research, get us papers, and then help us win awards. That's not what we do here. Every one of you is very precious to us, and our goal is to develop you and make sure you succeed so that by the time you finish your PhD, you can go on to bigger and better things. So as a result, we focus a lot on wellness related issues. So for example, today there is a Slack channel where any PhD student can, with just typing a few on their keyboard, they could reach out to me directly. And I checked it all the time, and we're able to resolve any issues, whether it's COVID testing, their payroll issues, or any concerns that they have. Every student has a direct channel to me, to the graduate chairs, and to our graduate coordinators, both within our research and academic services and also individual departments. We have a very active community led by GSAC, which is a social group for our PhD and master students. And regularly, we have two groups of student leaders, one from the Dean's Doctoral Advisory Board and one from the Dean's Doctoral Diversity Board. And both of these boards meets me on a monthly basis, where they help to raise concerns by students, and we brainstorm different ways to try to come up with ways to improve life of graduate students. And we have also now wellness workshops within the engineering school, where we hire external consultants who are expert on wellness to lead discussions on resilience, having a growth mindset, on stress management. And also we form support groups where doctoral students can come together in groups of 8 without any faculty, any staff, but with the aid of an external consultant to talk about their PhD life and exchange ideas and share their feelings. And I think these groups have proven to be very useful during these challenging times. All right, so that's all I have. Happy to take any questions. If not, I will hand the token back to Christina.
Thank you, Dr. Liu. So I'm going to try one more time with the screen share. Hopefully this time things will go a lot better, but I think it's important that you guys hear from our Dean, Dr. Vijay Kumar. So let's try this again.
Good morning. On behalf of my colleagues on the faculty and staff, I want to welcome you to this virtual event at Penn Engineering. Welcome to Penn, and welcome to Penn Engineering. I'm Vijay Kumar, Dean of Penn Engineering. My primary appointment is in mechanical engineering and applied mechanics. I also have secondary appointments in computer information science and electrical and systems engineering. I work in the area of robotics, and my own group consists of students from these 3 departments. I'm delighted to see that you're interested in graduate school at Penn, and just simply thrilled to be here to welcome all of you to Penn Engineering. Hopefully today, you'll be able to take your mind off the elections, the partisan fighting, and just take a step back and look at the bigger picture and explore opportunities that you will each have to make an impact on the world as a doctoral student at Penn. Yes, it would have been terrific if you could be here on campus, in person, but we're living the reality of the many ways that the coronavirus pandemic has changed the world. We are fortunate to be together in this virtual setting, however surreal it may seem to you and to me. Let me first tell you a little bit about Penn. We're a community of over 11,000 graduate students, over 4,000 faculty across 12 schools. Engineering is one of the 12 schools. In terms of the number of people on campus, we're about 10% of the community. But engineering is everywhere. Today, our faculty and students have collaborations with all of the 11 other schools. Interdisciplinary is in our DNA. Long before that word became a fashionable word, we were using it at Penn. Indeed, if you look at the structure of how doctoral programs are administered at Penn, it reflects that interdisciplinarity. When you're admitted to Penn, you're admitted to a graduate group, not to a department. The graduate group structure allows students and faculty from different departments, different schools to come together as a cohesive unit. So for example, if you're a student interested in medicine and engineering, you would apply to the biomedical graduate studies group at Penn. If you're interested in bioengineering, you would apply to the School of Engineering. So these graduate groups include faculty from different departments in different schools. And this is to foster interdisciplinary thinking. I want to reflect a little bit on what constitutes a PhD. I'm going to quote the most unlikely of people, Donald Rumsfeld. Donald Rumsfeld was the U.S. Secretary of Defense under George W. Bush, and he's famous for one of the most bizarre quotes. He was discussing national security threats when he said the following. He said, there are known knowns, and there are things that we know, the known knowns. But there are also known unknowns. That is to say, there are things we know that we don't know. Those are the known unknowns. But he also said that there are unknown unknowns. These are the things that we don't know, And of course, he was lampooned by the press because this sentence is utter nonsense. But if you think carefully, there's some truth to this. There are known knowns, there are things that we know now, and that's what you learn in coursework, so you know more. There are also known unknowns, and that is to say there are things that we now know we don't know. And that's what you do in research. You know what you don't know, and you investigate the unknown. You develop tools that allow you to navigate the unknown. There are things we don't know that we don't know. And this is where research gets interesting. Investigating the unknown and getting to know the unknown. And occasionally when you get totally unexpected results, you learn the unknown unknown. And indeed, doctoral students are the key to investigating the unknown and learning more about the unknown unknowns. And that is why our doctoral programs are our top priority in the school. We as a school are ranked by how well our doctoral students do. On a personal front, I have graduated 50 doctoral students, and I have a special bond with each one of those students. And our faculty share this sentiment. Our school is growing. We're hiring faculty in all departments. Our doctoral student population has grown 75% over the last 4 years. Indeed, our commitment to doctoral students has never been stronger. And we're building new facilities with collaborative research spaces, with space for doctoral students and for laboratories, with active learning classrooms. And this is growth that's happening across all departments in the School of Engineering, but it's primarily in 3 areas. First, engineering health, where I use engineering as an adjective. This reflects our partnership with the 4 top-ranked health schools in the university. Indeed, if there were ever a time to double down on this partnership, it is today, in the midst of the pandemic. Whether you're talking about accurate, instant, cheap, and portable tests for the coronavirus and its antibodies, or testing frequently on a mass scale, or you're talking like I do about robotics to reduce the amount of direct patient support while ensuring the safety of caregivers, performing some of the routine patient management functions using robots. Partnerships between engineering and medicine power the innovation on campus in this area. Indeed, when you come to campus, we will have tens of thousands of tests a week with mandatory testing for everyone. And that'll be possible because of these partnerships. The second area of growth is data science. And this is a trend in all disciplines in engineering and science, where data-driven approaches are now increasingly being used in addition to classical techniques, which are model-based. They're being used for research and for commercialization. I sometimes joke that if Sir Isaac Newton were to be alive today and he had to discover the law of gravity, the laws of motion, he might have pulled out an iPhone and taken pictures and described the fall of an apple from a tree using video information and using data. And he might not have even invented calculus, because the lingua franca of data science does not require calculus. Just to give you an example of something very concrete that you might not immediately think of when you say data science, let me tell you about a center we have. This is a $28 million center on precision agriculture. Penn does not have an agriculture school, but the pressing challenges today in food security, reducing water consumption, and increasing the yield per square foot on our planet, these challenges are related to data. The more we know about individual plants, the more precise we can be in administering inputs like water, like fertilizer, pesticides, and the more efficient we can be. Thus, data science will directly impact our global challenges that we face in food security and also food shortage. The third area of emphasis is energy science and technology. This addresses the most pressing problems our planet is facing with respect to climate change. I don't have to tell you this. Atmospheric carbon dioxide concentration recently surpassed 400 parts per million for the first time in several million years on our planet. The world is now a degree centigrade warmer than it was before the Industrial Revolution. We're investing in a new building that'll focus on catalysis science and technology, storage technologies, upcycling plastics, and many other engineering challenges. You're not on campus. So I thought I would do the next best thing to visiting the campus. This is a video taken from one of our drones on a beautiful fall day. Here you see Hayden Hall, the home of bioengineering, and you can see across the street the stadium. And now this is Town Building. You're looking down at Town Building, and the green building that you see on the right side is Kirkanich Hall, also the home of bioengineering. And on the left side, you see the Moore Building and Levin Hall. That's the home of computer science and electrical engineering. As you cross the street on the right side, you see where physics is in David Rittenhouse Laboratory. And in a little bit, as the robot pans across the street, you will see LRSM on the right side, the home of material science, the Singh Center for Nanotechnology on the far right in the middle, which is this futuristic building with a cantilever at the end. And if you look straight ahead, you'll see this ugly garage, which we hope to obscure very soon with our new data science building. That's going to be a 120,000 square foot building that's going to go up soon. And then on the right side, and you really can't see this, I apologize for that, next to the David Rittenhouse Laboratory, and of course DRL is on the bottom right of your screen, we're building the Vagelos Energy Science and Technology Laboratory, which will be the home for energy research in collaboration with the School of Arts and Sciences. So this is a snapshot of the Penn campus, the Penn Engineering campus. And one thing you will realize is that the density of the campus. And this is one of the intellectual values of the Penn Engineering campus. Our proximity, the chance interactions that happen between students, faculty from different walks of life, leading to new ideas. And this video illustrates the energy, the vitality of the Penn Engineering campus. As you think about Penn, you should think about not just the university, but also the city. A city where you might spend the next 4 to 5 years of your life. Penn is the best urban campus in the US. It's the only university with this proximity, the intellectual density. And we're right across the street from 11 other schools, including the top-ranked medical school. Philadelphia is a beautiful city with lots to offer, a very walkable city. Indeed, I live in the city. I don't use a car. I walk to work. Many faculty also live in the city, and certainly most students live in the city. And that gives Philadelphia a very unique character. Penn is a welcoming campus. We're very diverse in every sense of the word. Our core values emphasize scholarship, creativity, and curiosity. Second, integrity and character. Third, we are an inclusive community of diverse people and diverse perspectives. Some of you may be international. We are very global. We have over 5,000 international students at Penn. At a time when anti-immigration rhetoric is at its highest, I want to remind you that it's not lost on Congress and federal agencies in Washington, D.C., that international talent has driven much of the innovation in the United States. Sergey Brin was an international student from Russia. Elon Musk was an international student from South Africa. Sundar Pichai, an international student from India. Jensen Huang, the CEO of NVIDIA, an international student from China. Steve Jobs' biological father was from Syria. Indeed, Penn has always valued the international presence of students on campus and will continue to value them, and will continue to be a welcoming campus for international students. Once again, my regrets at not being able to be with you in a big room, to be host you in person, and to welcome you to Penn in person. But I do hope you'll get a great sense of who we are. You'll get a sense of Penn Engineering. And I hope you'll apply to our school. And then I hope to see you next fall. Thank you.
All right, thanks for your patience. So as we move forward, we've heard from our dean. We've also heard from our Associate Dean, Boon Thao Lu. Next, we will hear from Dr. Laura Stubbs, who is the Director of the Office of Diversity, Equity, and Inclusion.
Thank you, Christina. I'm going to share my screen. Let me see here. Oh, wait a minute. Okay, I can't seem to share my screen. Can you hear me, Christina? Okay, okay, here we
Yes,
go.
Here you have access.
Thank you. Hello, everyone. I'm so happy to see you all. I am, let me see, let me put this on. Well, as Christina mentioned, I am the director of the Diversity, Equity, and Inclusion Office. And we named this segment United We Stand well before we knew where we'd be in the country with the election. But United We Do Stand. We are so happy that you have come. I wish we were there in person, able to see you and you to go through our spaces and things like that. So I'm going to start off by sharing a little bit about our office and what we do and why we're so excited that you're coming onto the office. I must admit that Dean Kumar and Associate Dean Liu stole some of my thunder with some of the bullets, but that's okay because we keep saying the same thing because we truly mean it. Behind me, oh, that's right, I'm not sharing, I'm sharing. But if you were to look at in the gallery or on the little screen, behind me is my office. And my office is in, see, I keep hitting buttons. My office is in the town building, 125 Town. So if you were here, you would be able to stop by or at least walk past it. But when you do come to Penn, I'm confident, then please stop in. All right, so let's get started. So our office, the Office of Diversity, Equity, and Inclusion, we have a long history. It is staffed, the physical office is staffed by two of us who are Penn alums. Myself, I received my BS and MS degree in Mechanical Engineering and Applied Mechanics right here at the University of Pennsylvania. And Ms. Yolanda Soka, our Associate Director, received her BS and MS degrees in the School of Arts and Sciences here at Penn as well. There is a link to my website, and I will also put the website in the chat. What I'm really proud of is the fact that our office, next year, we will celebrate our 40th anniversary. And you see, I'll talk about what we do, but you see here some of the activities that we have, primarily with undergrads, but I'll talk about how our graduate students and specifically how our PhD students also are involved. We do host research, poster sessions, research symposium, where students work in the lab, and you as graduate students, we rely on you to help mentor those students in the laboratories and with your graduate groups that the deans talked about earlier. We also sponsor students, undergraduate and some graduate students, to NSBE, to SHIP, Society of Hispanic and Professional Engineers, ACES, American Indian Society of Engineering, as well, and other conferences like Grace Hopper, etc. All right, here's a little bit about me. I am a native of Philadelphia, PA. I got my start in the bright light dawned for me when I attended a Women in Engineering program while in high school. That was at the University of Notre Dame, and that was the first time I ever flew on the plane, was to go to that program. These programs, Women in Engineering, Youth in Engineering, summer engineering programs, they're quite frequent and quite, you see them all around right now at the various universities, your local universities, etc. But this was just starting back over 45 years ago. Like I said, I received my BS and MS from UPenn, My PhD is also in mechanical engineering from the University of Maryland at College Park. And upon graduating with my master's from Penn, I joined the Navy. So I have active duty naval service. I entered as a nuclear power school instructor. At that time, women could not go on submarines, which is what I wanted to do. But by law, we could not. So I taught folks who went on submarines and our nuclear surface ships. And then I spent a long career in the reserve. So what turned out is, gee, I just want to do 4 years in the Navy, turned into 30. I had worked in industry, nuclear power, worked at a Davis-Besse nuclear power plant in Ohio after I left active duty service and consumer products, and have also a long career and retired from both the Navy and civil service, my federal government service with the Navy and Department of Defense. So I remember Secretary Rumsfeld that Dean Kumar just talked about. I include on this picture a photo of myself and my advisor, Dr. Marino DiMarzo at University of Maryland, College Park, because you and your relationship with your advisor will be one of the key that you will have for the rest of your life. So you will have, of course, relationship with folks in your lab. I keep in touch with my graduate group. My postdoc in our graduate group just wrote to me a couple weeks ago. I asked them how the kids are doing. They're growing. I keep in touch with other folks who help me with my experiments. I help them with their experiments. So these relationships that you build are key. Our office, as I mentioned, has some signature programs, but we provide long-term support for all students. I am the university representative for the National GEM Consortium program. Some of you on the call may be applying for a GEM fellowship, and this is a cohort from 2 years ago. We actually don't have a picture with our cohort from this fall, but we have about the same number of students. We had 6 come in this year. We had 7 come in last year who are GEM fellows. Some of you may know about the greater the Lewis Stokes Alliance for Minority Participation. We do have the Greater Philadelphia chapter here, and Penn is a charter member. We've been a charter member for the last 26, now going on 27 years. So what do we do under those auspices? We provide freshman coaching program for gateway math and science classes. So sometimes graduate students will coach our undergraduates. That is a paid position out of our office. We have summer undergraduate research program similar to REUs that you attend, except the students that come to our summer undergraduate research come from Penn, as well as our Lewis Stokes partners. Once again, many of the graduate students here, and you would be the same, they mentor students because the students would work in the labs. It's a paid position for the undergraduate students. And we host other programs. We're doing these virtually now: study breaks, yoga and meditation. Namaste. Trivia nights, and we just had a trivia night last Friday. But basically, we have at our study breaks, we would gather together in the room. We'd all share a meal. Most it was lunch, sometimes it was dinner, and we loved it. Graduate students came as well, and they would share their journey, present their research, talk about their innovations. We have a PhD student here who has a company and talks about how he came to found his company with a friend of his in bioengineering. We also help students collect with Penn alumni. We have other folks who've been through the GEM program. We have other people who've been through the PhD program, master's program, et cetera. They come back. I know I used to come back and just stop by the office before I returned to Penn 3 years ago. And you do some like on the spot mentoring, but they're great for bouncing things off, for bouncing ideas and getting ideas about career opportunities, whether to go into industry or to go into research. This year, the university has offered over several years something called Campaign for Community Grants out of our provost office. This year we received a grant or that our office specifically applied for because there was so much social unrest that we got together. It was sort of like a book club, paper club. We talked about social justice. We talked about Black Lives Matter. We talked about what's going on in the world. and how we can help each other. And it was a small group, so it wasn't that large because there weren't many students involved. It was during the summer. It was mainly the students who were in summer school, but it didn't have to be. There were faculty members, there were staff members, there were students who all participated and got a great benefit from that campaign for a community grant. I do bring you greetings from my boss, Associate Dean, Professor C.J. Taylor. He's in the CIS department with Dean Liu. He is our Associate Dean for Diversity, Equity, and Inclusion. And I wanted to talk to you a little bit about some of the focus areas for DEI here at Penn. Some of our strategic DEI initiatives, and you hear us talk a lot about it. There are three: climate, recruitment, and retention across everything. Across students, graduate students, undergraduate students, we're looking at recruitment and retention, as well as faculty members. It's important that you as faculty members see people and interact with folks who look like you. So the dean mentioned and Boone mentioned building community. That's why I said Dean Liu mentioned building community. He also mentioned the Dean's Diversity and Inclusion Board, how it meets monthly. And so I'm not going to spend a lot of time going through those, but just know that climate, community, inclusivity is very important to us here. And we take it seriously, and we have a lot of resources and opportunity for you as students to interact with students, both in engineering school. GAPSA is, you're automatically enrolled if you come, a Graduate and Professional Students Association that's across the whole university. And we do have opportunities for outreach, K through 12 outreach. We have a new project called Invenium, which is a partnership with Stepping Stone, the local Philadelphia school. Access Engineering, which is with a local nearby school where they do experiments and things with high school students. We have Upward Bound Math Science, NSBE Junior, all kinds of opportunities to interact and influence K through 12. I'm not going to, GSEG and the department, graduate student organizations, mention those. Like I said, GAPSA, and then there are some other offshoots of GAPSA, BUGAPSA, Black Graduate and Professional Student Association, LUGAPSA, Latin American Graduate and Professional Student Association. One aspect, some of you may have already applied for a National Science Foundation Graduate Research Fellowship. I wish you well on that. You won't find out until, if you recently applied, you won't find out until the spring. But we have resources to help you, even though the center says Center for Undergraduate Research and Fellowships, CURF. You probably have something like this on your campus as well. CURF also has graduate student resources, a whole section is dedicated, and can introduce you to various other opportunities for grants, fellowships, etc., related to your research. They have a searchable fellowship directory, and they have application workshops, and they will review an application, so that's also available to you. And not only do students use them, faculty also receive help and assistance from CURF. Now, you heard both Dean Kumar, you heard both Dean Liu talk about interdisciplinary aspects here at Penn Engineering. Well, just as our departments are interdisciplinary, our cultural centers are sort of like interdisciplinary for your soul. We work together with the cultural centers across Penn. I'm going to quickly step through what's going on with the cultural centers. Oh, I see we're a little bit, I just looked at my, the time here, but the Greenfield Intercultural Center, and I have a picture here of the director of each one of them, key programs in constituency. They host Native American initiatives, something that's big here on campus, first generation and or low income. Penn First is the group for undergraduates, but we also know that there are some graduate students too, who were first in their generation to not only finish with an undergraduate undergraduate degree, but go on to graduate school. And we have international first generation students as well. And we have support for documented and undocumented, and as we say, documented students. McCoo Black Cultural Center, the director, Dr. Brian Peterson, is also a graduate of Penn Engineering. He returned to Penn and has a large leadership position. The McCoo focuses on the African diaspora, as well as other cultural and impactful for African and African American students. But anyone who has that bent and wants to work with McCoo can do so. So we work across the spectrum with all the cultural centers. Casa Latina, Center for Hispanic Excellence, they have an interim director, Lazaraga, and the La Familias. La Familia, we love La Familia. You saw it on the ship as well as Casa Latina. Each one of these areas also have a space where students can go and participate. Yep. Patch, Pan Asian American Community House, Director Peter Van Doo. I see all my friends as the directors, my equivalent directors. We love getting together. We have a good time when we all get together. And whenever we come back on campus, they come to our programs, we go to their programs, and it's a good time. We have an LGBT center. It was one of the first in the country here at the university level, enriching and providing also training and acclimation to what LGBTQ plus students experience and go through, and how we can make things more welcoming and a community for LGBT. The director, Erin Cross, provides training, she and her associate, called Safe Space Training. And what you see, you'll be able to see as you walk through the engineering school, there is a sticker on the doors and inside the offices that is a rainbow sticker and says that we've been through the training, so that we have more increased awareness and understanding of sexual and gender related issues. Erin has also made a list of all gender bathrooms across the university, and it's available online. And she also has a little booklet that you can obtain that lists all the all gender bathrooms. And there's also accommodations as far as inclusive housing, which does not require that it's assigned based on binary assignments. We have the Women's Center, which preceded the LGBT Center, but working with all genders and identity. Kind of touched upon some of the transgender LGBT aspects prior to the LGBT Center, but like I said, all of the centers, we all work together. And here is the director, Dr. Laud Hammond. All right, I mentioned Penn First. For the undergraduates across the whole university, we have the Penn First Plus program, and myself and Michelle Rainey, who's the director of our Advancing Women in Engineering program, we are the liaisons for the engineering school. Okay, I think I'm getting down to the end. All right, so that's the end of my slides there. I mentioned Dr. Berdonia because as part of our diversity and inclusion, we are going to host a lecture named after Dr. Berdonia. He mentored me when I was here. He was the undergraduate dean, and we welcome you with open arms. Inclusivity, equity, diversity is very important to us. Thank you, Christina. Okay, wait a minute, do I now have to stop share, right?
Yes, thank you, Dr. Stubbs.
All righty.
So next we'll go into some of our research tours. So we're going to have Dr. Gerald Lopez, who's the Director of Business Development at the Singh Center of Nanotechnology, give us a little tour.
Good morning, everybody. Thank you, Christina, for the introduction. And I'm really happy to see so many faces. For those that want to share your video this morning, just to get a feel for who's here. Do we have any, can you guys type in the chat your state that you're from, or even your country that you're from? And everyone can get to feel as to where everyone's dialing in from. Pennsylvania, Texas, Illinois, Alabama, North Carolina, Florida. I mean, this is incredible, right?
Wow.
It's a wonderful place to be, despite the pandemic, that we can find the positives of actually being together in the same place while we're at the same time alone, right? But what I want to emphasize here is that, you know, we have international students, right? Turkey, Iran, just popped up here, China even, right? We understand the commitment and the time that you've made, no matter what time zone you're in, to be part of this event. And I want to, you know, extend that appreciation, at least from the Singh Center. So before I begin, I'll talk about a little bit about myself. So I'm the Director of Business Development. I received my PhD in 2009 from the Georgia Institute of Technology in Atlanta, Georgia. I am a Maryland native, born and raised in Maryland, and went to University of Maryland, Baltimore County, and from there I got my PhD at Georgia Tech. Spent some time in industry, and then shortly thereafter, one of my customers plucked me out of industry, and that was UPenn, and I'm now here, and I've been here now for 5 years. So let me get started. I'm gonna go ahead and share my screen and share this one. And let's launch this. And let me make sure I swap to this. Okay, everyone good? Can we see the proper screen? I say that because I've seen so many times where they show the other side, right? The presenter side. All right, so the Singh Center for Nanotechnology. This is the physical manifestation of the interdisciplinary being that is SEAS, right? And it is the first multidisciplinary center on campus, actually. Now, I'm going to give you, I've got about 41 slides here. Most of them are pictures and talking about the center and the research. So I'll go through them hopefully very quickly. So the Singh Center, what is it? It is basically composed of 3 core facilities: the clean room, the scanning probe facility, and the electron microscopy facility. So the clean room is mainly the reason why it's here. It's this, what gives this bright glow of orange that you see when the sun's setting. And the other 2 pieces, the scanning probe and electron microscopy facilities, those have been here. Those actually have been staples of SEAS for some time, and they're also now part of the Singh Center. So just to kind of give you a feel as to where we sit on the national level, as far as the Singh Center is concerned in UPenn, we belong to the National Science Foundation's National Nanotechnology Coordinated Infrastructure. This is basically a group of 16 universities that represent the basically starting point for nanofabrication and nanotechnology resources that people may need, for instance, for startups or for companies that don't or can't make the investment for capital equipment to actually further development in their own organization. And being what we are, we're called the Mid-Atlantic Nanotechnology Hub. We were awarded about 5 years ago a $10 million grant by the NSF, and that's basically to help be this catalytic force of nanotechnology in the Mid-Atlantic region, right? But on top of that, we're doing that by granting access to all the state-of-the-art equipment, right? You're looking at about 60 million some pieces of capital equipment. So between Atlanta, Georgia, where Georgia Tech sits, and Boston, where MIT and Harvard sit, we are the largest collection of capital equipment in an academic nanofab. So as UPenn and the Mid-Atlantic region, we basically represent, or we're bookend between, of course, Washington, D.C. and New York City, for those of you that don't know. And we basically represent 5 government labs and 16 universities. So what does this mean? Why is this important for you? What this means is that if you can't get something done at the Singh Center, we have all these other regional centers that we work with, and we can have things done, what we call Fab by FedEx. We can ship out something, we can have something done and shipped to us. We also can go there, right, and work with them. So we actually have this huge interconnectivity within our region. As a matter of fact, the Mid-Atlantic has the world's highest density of academic nanofabs on the planet. So when you look at us, most of them are highly accessible from I-95. And you're always near some kind of airport or train station. Our furthest neighbors within this region is Carnegie Mellon all the way to the east end of Long Island, which is Brookhaven National Laboratories. And the closest neighbors are basically Penn and Drexel, which are basically on the same block, right? They're 1 block away. You can actually see it from the Singh Center. All right, so if you're building the Singh Center, you're building a place that's so sensitive to perturbations in our Earth's magnetic field and vibrations. And you look at where we are. We're in a city, right? You got cars driving by on Walnut Street, right? Buses, emergency vehicles, right? So they get those acoustic vibrations coming off the street. You got a rail line that takes you all the way to, well, wherever you want to go, even to the airport or beyond. You've got some trolley lines and some train lines. So you got these DC motors turning the Earth's magnetic field, always causing these perturbations, right? Well, we did a site survey and we discovered that, hey, there's a sweet spot where there's a minimum amount of perturbation, where, no matter how much these trains go by and no matter how much the cars drive by or the trucks, when we dig about 8 meters into the ground, we hit bedrock, right? And for those of you that are physicists, you know that nice large inertial mass gives us that resistance to those acoustic vibrations, right? When we lock the building into that. But then we're also, minimizing the perturbations for the EMI. We have noise canceling systems for our columns. So right in the Singh Center, when you look from it from above, you'll see that it actually points to that perturbation minimum. So this is the Singh Center. You can see the cantilever off to the right. And the way the pathway points right to the entranceway, the architects design it to point out that perturbation minimum, right? And right underneath the entranceway, as you step inside, is where we have 3 new transmission electron microscopes and some of our other columns that we do for research, electron microscopy columns. So I'll give you a little bit more. So most of these are just graphical images of what the Singh Center looks like. It's a very pretty building. It does feel like a spaceship. It definitely feels like one when you step under the cantilever being outside. But going on the inside, this is one of the things I love about Penn. When you step inside, it was the vision by our former dean that when you step inside the Singh Center, you should see research happen. Research should be transparent, right? As a grad student at Georgia Tech, we had a nanofab, and they still do. And like every nanofabrication facility or clean room, you usually find them downstairs in the basement. Well, that can be a problem. It could be wintertime in Atlanta, Georgia, and I'll go in at 5 in the morning because I want to get on the equipment early. So it'll be dark outside. So I won't even eat. And then what happens? It becomes 5 o'clock. I don't know where the time goes. And I come out, it's still dark. Don't know if it rained, don't know if it snowed, don't know if the sun came out at all. This is very different. And this is what makes, I think, research at UPenn very unique, right? That they took this initiative to kind of make that connection. The Singh Center is basically open to, and this is during pre-pandemic times, 24/7 to anyone that has access to the School of Engineering and wanted to go and find a quiet place to study, right? Whether it be on the lawn or inside, in our corridors, or upstairs on the cantilever, sitting and overlooking Walnut Street. So a little bit more about the Singh Center. So again, we're fabrication and imaging. Our annual expenditures is $2.45 million. Our revenues are roughly $2.2 million. Why am I telling you this? I'm telling you this because you should point out that we're not making any money. It's not a for-profit center. This is what it is. It really shows the leadership and the thought that went into building the center like this. They understood that building a center like this requires sacrifice, and then sometimes sacrifice for at the front end for research. to produce great research, you've got to sacrifice a little bit. So if we can't meet our expenditures, that's okay. They can get us covered because we're getting in grants that are over, I think the entire university receives over $1 billion in grants, right? And the last time I checked, when it came to just the professors and faculty in C's, they have about almost $750,000 per faculty in funding on average, right? And I think that's the highest nationally. That's why, and that's important for you to know that as grad students, because you want to know about the security you have in producing your projects and getting your PhD so that they're funded for during the time that you're here. And so that's something I want to make sure you understood. The Singh Center serves about 700 plus registered users. We grow annually. We serve about 45 plus companies, a number of universities, and these are for people that physically come in. And if you look at our internal, external users, 70% of them are serving the internal or Penn campus, and 30% are serving the external users. And I'll touch a little bit more about that later. And then, whoops, it looks like it's delayed here a little bit. Just to talk a little bit more about the Quattro Nanofabrication Facility, our NanoFab. This is an 11,000 square foot facility, open 24 hours, 7 days a week, pre-COVID. Right now we have to control and maintain distancing and so forth. But all major fabrication tools are interlocked, right? We understand usage patterns, right? We understand who's coming in, who's going out. So this is a layout of our NanoFab. So it's basically 5 bays interconnected by 1 main corridor. And that corridor is that orange glass wall that you see, right? So you have a gowning area, an area where you can do self-lithography. I'm going to talk a little bit about that. Other areas dedicated for doing thin film or metal deposition and etch, and lithography, which is patterning, which is actually my field of expertise. So when you have a NanoFab, and a NanoFab of this size, right, you're basically looking for 2 major components, which is lithography, which is patterning, and thin films, which is deposition and etch. What makes us unique is that we have a very dedicated space for soft lithography. Soft lithography is microfluidics. It allows us to do things like lab on a chip, and you're going to see some research projects about that. Now, why do we keep soft lithography separate from everything else? One of the main components of soft lithography is a fabrication with silicone. And if you ever had a caulk with silicone in a shower or a bath, it gets everywhere. And so we don't want that getting into our other equipment. Now, we were built for growth. And as Dean Vijay said, we're hiring. And as we hire, we need room to put new equipment somewhere. And we have an unbuilt 6th bay that is waiting for our new faculty to come in. So let me give you a quick tour of inside the NanoFab, so you can get an idea of what it's like to be inside. So again, this is another angle of the glass corridor, and we're going to go step inside. So there's a little map there, bring you inside the gowning room. This was one of my students. So even as a staff member, I actually started the Penn lithography group to help drive our processes when I first arrived in the area of patterning. And this is Margot McDonald. She's now a PhD student in biophysics at the University of Chicago, but she was very happy to model this for me. Everyone has to wear a gown, a bunny suit. So if you step out into the corridor, this is what I wanted to kind of point out to you, is that, again, you can see the outside. And like I said, you can see when it's sunny, when it rains. And if you pay attention to the left there, look closely, it actually just snowed. Now looking over here to the right, you can see how you have access to all the corridors. And the first bay is one of our deposition and etch bays, where we have furnaces that we can grow oxides. We have atomic layer deposition tools and some other metrology tools to measure thin film characteristics. And then in the second bay, we have metal deposition tools, etch tools in the back, and then we have a dedicated stainless steel wet bench there to do liftoff, to complete a patterning transfer process. In the center, it's kind of where the convergence of thin films and patterning come together is where we have our wet processing bay. And then in bay 4, well, a little larger, and this was my original domain when I got here, is where we handle a lot of the nano patterning. Right? We have a wonderful laser writer that people can pattern directly onto wafers without having to use a mask, if you're familiar with that at all. And then inside at the front, we have our E-beam lithography tool that can pattern really down to tens of nanometers in scale, even with your eyes shut. And then lastly, I'm going to take you to look at the other end of the corridor so you can see how that looks. And we're going to slide right inside here into the last bay. And so in this bay, you have some spinners onto the left for spinning up the resist onto your wafers. You have a mask aligner, and actually what's not shown here is a 3D printer that's called a nanoscribe that prints 3D objects at the nanoscale. So our nanofabrication capabilities expand into 3 realms, right? Lithography, thin films, and soft lithography. And when you're looking for a school and you want to do hands-on research, there's nothing like having fabrication capabilities and obviously metrology capabilities to see what you're doing. A little bit of a snapshot so you get a better idea of what we're looking at and who actually is going to be inside the nanofab and inside the Sing Center. So I know I said earlier we're about 30-70 external, internal. The numbers change when you look at participation from other activities that we do, for instance, bringing high school students and so forth, and having them tour the center. But looking at how we break down, our strengths and our pillars are MEMS and mechanical engineering, quantum physics, optics, right? Life science and medicine, materials especially, right? And if you look at our external affiliations alone, you're seeing that it's the external academic research is large in part who's coming in, right? But you might also run into large companies that are working there and small startups especially, right? And that's important because we pride ourselves as a community to make those connections, because once you are done at Penn, you just don't leave, right? You do leave with all these wonderful connections. And we can help bridge those connections for you, especially if you're out job hunting as well. And just a little bit more about our external use, so you know that, hey, there are other people coming in here. We have seen dramatic use in terms of large and small companies in life science and medicine, right? A dramatic use in physics, quantum, and optics for external academic, including MEMS and mechanical engineering. And of course, for materials, we've seen the steady growth of all these large companies coming in, working on new materials as well. So what do you make at the Sing Center? Well, you can make graphene sensors, you can make microfluidics, you can make implantable electrodes, you make nanophotonics, flexible electronics, you might have seen those, microneedle arrays, right? One of the cool things that I've done and I helped with was this one paper about a flat lens, a meta lens, right? Now, what was so important about this lens? Well, nitrogen vacancies in diamond, for instance, are one of the main things that they use for making quantum devices. And, the refraction and reflection at these material interfaces kind of impede the electron collection that these things emit, right? So to overcome these limitations, when I came in as an expert here to help with the fabrication of this meta lens, we designed this meta surface, right? These nanoscale diamond pillars that act as an immersive lens to collect and collimate the emission of individual nitrogen vacancy centers, right? What I'm proud about it, and is the fact that we did it on the first shot, right? As a staff member. But I think what's also really cool about this is that, right, it's the inclusion, right, of having all these teammates trying to get together and make this happen, right, and actually get it to work the first time around. One of the other pretty exciting things that does get a lot of press is our massively paralleled microfluidic array droplet maker. And the applications for this are really endless. What is so significant about this? Well, this is basically liposomal encapsulation of whatever you want, right? Taking oil and water, basically, but doing it in such a uniform and monodispersed manner, right? But what's more important is really the bandwidth that you can do this, right? The output that you can produce this at. And what they did was, Professor David Isidore did, is that they basically mimicked very similar things in electronic circuits to get the same parallelism to come out. And now they're talking with several drug companies in the area. And if you didn't know this, about 87% of the drug companies in the US have a footprint in Philadelphia. And so that's kind of our focus here, is that trying to help them improve, for instance, cellular uptake of some of these drugs, or time to release, right? And you can change that as you modulate the thickness of the liposomal wall. One thing that not many people don't know too much about when it comes to space travel and zero gravity is that some of these astronauts often get sick and have some problems with upper respiratory infection. And so what they wanted to do is they wanted to actually create basically mimic the human immune system on a chip. And that's exactly what they did. And they launched it into space. And they're using this platform, right? This this basically organ on a chip platform to understand the effects of zero gravity on the immune system. And I think this is just a wonderful thing that, again, the Singh Center was part of, because we have this dedicated self-lithography space to do that. But what's also cool about all this is that even if any of you have never touched nanofabrication before, we teach it from the ground up. You don't have to learn it. I didn't know it when I was in grad school, and I had to learn it too. And so we will actually take you through microfluidics courses and teach you how to make your own droplet makers, or teach you how to make your own microfluidic array structures to do mixing and discrete mixing, and so forth. And then you take that device and you take it back to your lab and you apply it to whatever you need to do, right? So don't be scared if, hey, you're talking about all this stuff, I have no idea what it is. So one of the other things I want to talk about is that, again, I talked about a lot of Penn research, but there's over the river at Rowan University, we have people coming over and doing research with us. And basically one of the research highlights I want to show here is basically this iridium oxide and surface coatings. What's neat about this is that they're really interested in information or ion exchange and at the biological level. And to do this, right, they're understanding how iridium oxide can change its morphology through changing the deposition parameters, which therefore changes the surface area, right? And if they can master that, they can better understand these biological pathways and how they communicate, and improve communication if we were to synthesize it on our own. There's other opportunities here. As a grad student, you can be a mentor to a research undergraduate for the summer. And many of the alums do go on to their own PhD programs. So, you'll have some impact there if that's something in your wheelhouse that you want to do. What you also will run into are, startup companies and, that are raising money and actually making devices. One of the companies I want to highlight is VZ Technologies. They discovered a way to actually create an implantable device that helps release the ocular pressure inside an eye for glaucoma patients, right? And if you've ever have seen some of the devices that you use today, they're a little bulky, and a lot of the operational procedures are very invasive. This will actually serve, and I don't know if you can see close enough, as a small membrane that allows the eye just to tear out the extra fluid that it builds up, right? It's absolutely fascinating. Actually, I had a hand in how this was all, long story short, having this come to be, but it's really a wonderful project that has taken off, and they just recently received a $1 million SBIR Again, I just mentioned we have wonderful new capabilities, transmission electron microscopes that are there. We have a general purpose Joule F2 that just got installed, along with an aberration corrected NEOARM. And then we have this wonderful cryo-TEM, which is used to image things down to the smallest viruses, right? And understand morphology of DNA. So with that said, just to remind you, the Sync Center is the clean room. It's an imaging center as well. And what makes us different is that, again, it's our accessibility, it's our location, right? We have trainings and workshops. So if you don't know what you're doing or you need help, the staff is there to help. And then, again, you get the professional support as well. And if you have any questions, you can reach me at my email at lopezg@upenn.edu.
Thank you, Dr. Lopez. Because of time, we're going to try to move things along a little quickly. So I'm going to ask that Dr. Duncan Watts, who's a professor, speak about some of the research he has going on that's very interdisciplinary. Dr. Watts?
Hi there. Okay, thanks for having me today, and great to see you all there on your little screenshots. I'm sorry that we can't be meeting in person, but really delighted to have a chance to talk to you today. Let me just share my screen here. So I've been asked to talk about integrated research at Penn Engineering, but as I'll explain, I'm a relatively new faculty member here, so I'm not really sort of qualified to speak about all of the integrated research happening at Penn Engineering, and I'm really just going to focus on what I know about. So maybe I'll tell you a little bit about myself just very quickly. I'm the Stevens University professor and a PIK professor here. It's a Penn Integrates Knowledge professor. It's a program that the president started in the early 2000s to appoint certain faculty members across multiple schools. My appointment is across engineering in the computer science department, the Annenberg School of Communication, and the Wharton School in the Operations, Information, and Decisions Department. And so the whole point of these professorships is to try to integrate knowledge across the campus. And really that's what I've spent my whole career trying to do. I started off with my bachelor's degree in physics at the University of New South Wales in Australia. I did my PhD in theoretical and applied mechanics in the engineering school at Cornell. I then did postdocs at Columbia University, Santa Fe Institute, MIT for a few years before switching fields and becoming a sociologist. And I taught sociology at Columbia University for several years. And then just as I was becoming comfortable thinking of myself as a sociologist, I left and worked mostly with computer scientists at Yahoo Research for several years, and then Microsoft Research. And I've just last year returned to a university here at Penn, where I'm now sort of trying to pull all of these threads together. And so my has gone through a few phases over the years. My early work was in what we would now call network science, using simple mathematical models and computer simulations to understand problems like the spread of influence or disease across networks, a topic that is pretty relevant right now as we experience this global pandemic. From the mid-2000s onward, I started working on what we now call computational social science, using the increasing amounts of digital data that are available through various online platforms, email, social media, e-commerce, and so on, to either do large observational studies of naturalistic human behavior, or to design web-based, what we call virtual lab experiments to sort of take the historical model of lab experiments from physical labs and putting them up online. I'll talk about that a little more in a second. And then finally, in the last decade, I've gotten very interested in what I you might think of as meta science, which is, how do we understand what we're doing when we do science? And I'm very interested in the relationship between explanation and prediction and interpretability, both in everyday context, in the form of, or in the domain of what we call common sense, and also in social science. So what is computational social science? I mentioned it briefly. It's the use of digital technology and data that is of a totally different type and scale than we're used to in the social sciences to study problems that are familiar to sociologists, psychologists, economists, and political scientists. It also allows us to run experiments at a speed and scale that is, qualitatively different than what we've been able to do in the past. And it's not just about having more data or doing things more cheaply. It also allows us to develop new approaches to old questions and even ask new questions altogether. So I just want to very quickly emphasize that this big data really is different. It has lots of problems. It's noisy. It's biased. It's often incomplete. Sometimes we don't measure the things that we want to measure. There's lots of challenges that we are facing, but it does allow us to ask different sorts of questions. We can take novel approaches to causal inference by adapting methods for data mining to find natural experiments in observational data. We can map out networks now of very large organizations and compare them across multiple organizations, which is something that was really just impossible to do until very recently. We can really map out the spread of information in a very detailed way across billions of events on social media. We can look at how people are consuming information, another really relevant topic right now as we experience unprecedented levels of political and affective polarization in this country. We want to know, where are people getting their information from, and how are they spending their time online as well as on TV? And this is increasingly the sort of question that we can answer. In terms of experiments, we're working hard to try to expand what we think of as the feasible design space of human subjects experiments. That historically, the kinds of experiments that we've been able to run are for small groups of people working together or alone for short periods of time, doing extremely simplistic toy exercises that have trouble generalizing to the real world, where in fact we have large groups of people interacting in very complicated ways over long periods of time. And the idea of porting this model over to a virtual environment is that we can try to expand this feasible design space. So this little red plane here is the region, rather, down near the origin of this made up three-dimensional space, and we're trying to push out that boundary to get closer to where we want to be. And finally, I would note that this field of computational social science is extremely integrative, extremely interdisciplinary. There's a fantastic conference that I've been involved with for several years now, the International Conference for Computational Social Science, and this is a picture of the disciplines that were present at the last event well, I guess the most recent one was at MIT, but the one before that was in Amsterdam. And this is a picture from the Amsterdam conference, and everybody wrote down the field that they're coming from to computational social science. And you can see that there's a lot of movement across and between these disciplines. Currently, I'm working on a few different projects that could be of interest to people in this meeting. The first one is a project that we call Project Ratio, which is about measuring the production, consumption, and absorption of media of all different types. At the moment, mostly web media, news and other media that is produced on the web and also on TV, but we're soon expanding that to include radio and mobile consumption as well. So we were interested in the production, what are publishers and producers and broadcasters saying about the world. We're interested in consumption. How do people encounter that information, and what do they pay attention to, and what do they not pay attention to? And then finally, we're interested in what consequences that that consumption has for understanding and engagement. And a second large project, we're interested in building software infrastructure and also new methods to run lab experiments at a dramatically faster pace, at larger scale, and with much more complex experimental designs than we've been able to do in the past. And that really ultimately is our objective is to develop a new type of a new way of building theory in the social sciences, that traditionally people have sort of sat down and thought very carefully about why people do what they do. They've come up with some theory. They then design an experiment to test that theory, and that test really only applies to the very specific context that they were studying, and then somebody else subsequently picks a different point in the space of all possible exercises that one could come up with, and does a similar procedure. And then, over the course of decades, we get dozens or hundreds of these different isolated attempts to theorize about human behavior, but we don't have any way of connecting them together. And so this new approach is to try to take more of a sort of machine learning approach to theory development and look at the entire space of the entire feature space of experiments, and build machine learning style models that can explain behavior over that whole space. A third project it just began this year, exploiting human mobility data that comes from cell phone location to measure how people are moving or not moving around the city of Philadelphia, and to use that to inform predictive modeling. And then finally, I'm again going back to the sort of meta science project or interest. I have another project on trying to characterize common sense, which might sound like a strange thing, because of course we know what common sense is. We all have it, don't we? But it turns out we actually really have no idea what it is. And from our preliminary results, it seems that common sense may not even exist in the way that we think it does. So this is a really fascinating new project that I'm working on. Currently, I have several PhD students from computer science, from Wharton and from Annenberg. My postdocs also have quite different backgrounds in computer science, in engineering design, in management. I have collaborators across Penn and other institutions, and I'd be really excited to talk to you if you have an interest in doing this kind of interdisciplinary team-based research. So I'm already over time, and I apologize for the speed of this presentation, but I hope this gives you some flavor for what is possible here at Penn, where I think among the many universities that I've been involved with over the years, I think Penn has an especially a special openness to research and thinking that spans across our many schools, and also I think driven in part by Ben Franklin's mission statement for the university, which is to advance practical understanding as well as the what he called the decorative arts. So we care about basic science and advancement of knowledge, but in a context of making it matter to the world. And I think that's where the interdisciplinarity in this research comes from. Thanks very much.
Thank you, Dr. Duncan. And now, without further ado, we will hear from Dr. Ani Shea, who will talk about the GRASS Lab. She's the Deputy Director of the GRASS Lab.
So thank you guys for coming. It looks like we have an awesome full house. And so today I am actually going to take advantage of the virtual format and ask you guys to put on your virtual walking shoes and sort of go on a tour with me. The virtual walking shoes is extremely important because this actually would not be possible if we were in person, given the fact that, GRASP at this point has expanded and we are now split in two different physical locations that in practice is about 1 mile walking distance apart. So without further ado, let me just get started. It is, sort of, unfortunately, due to scheduling purposes, this is actually happening concurrently with our weekly GRASP on Robotics seminar. And today our seminar speaker, just in fact, happens to be our illustrious founder, Dr. Regina Bacci. So the lab was founded in 1979. And so this is actually the earliest robotics lab in the country. We actually, Robotics Institute at Carnegie Mellon was also founded in 1979, although they claim that it was started in the fall of 1979. So for today's purpose, we're going to assume that GRASP is, just a little bit older. And it's housed, of course, in the School of Engineering and Applied Sciences at the University of Pennsylvania. And our mission is really, since the lab's inception, has always been about creation and integration of knowledge through scholarly research, entrepreneurship, innovation, and of course, education. So today, the GRASP lab actually consists of 19 primary faculty members. The faculty, so here's a quick snapshot of all the faculty, primary faculty in the lab. We are spread out across 3 departments in the School of Engineering and Applied Sciences. And we even have Professor Michelle Johnson, who is a sort of associate professor in the med school. We have 4 affiliate faculty, and that is growing. Affiliate faculty sort of are within other departments of Cs as well as medical school. And then we have about 25 staff, which includes admin, engineering, support, postdocs, research scientists, over 100, actually approximately 100 PhD students. Again, those PhD students are spread out across the various departments in Cs. And then over 160 robo-MSc students, okay? And in fact, we're still growing. And so, we're hoping that we will be able to sort of add to these numbers in the next few years. Now, unfortunately, I was trying to see if there was a nice visual that I could use to sort of encapsulate all the types of robotics that we do. So from a sort of fundamental research perspective, we cover just about everything from mechanisms, design, computer vision, perception, any kind of robot perception problem. We effectively, that is covered. In fact, Dr. Regina Bacci was one of sort of the early pioneers in computer vision for robotics applications. Planning, estimation, control, so things like self-driving vehicles, mapping, exploration, so we do a lot of that. Machine learning and artificial intelligence, multi-agent systems, human-robot interaction, and given the presentation from the same Nano sort of Fabrication Center, we actually also have faculty that works at the micro and nano scale. So super tiny robots that can potentially one day go into your bodies and for applications like drug delivery and sort of medical intervention. So from an applications domain, we were just going through this the other day, and we were trying to figure out if there was any domain that we do not cover as of yet. So we cover flying robots, we cover ground vehicles, so any kind of driving vehicles, walking robots, we cover marine robotics, we do medical and rehabilitation robots, all kinds of environmental monitoring, things like sort of trying to monitor sort of orchards, fruit orchards, so things like agricultural robotics, underground environments. So Penn actually fielded one of the DARPA Sub-T Subterranean Challenge robots, mapping and exploration, autonomous driving, manipulation, human-robot cooperation, and of course, medical and assistive robotics. And I'm positive that I probably missed sort of something or another. So for those faculties whose areas that I missed, I apologize for that. So as I mentioned earlier, today we were actually split in two separate locations, GRASP at Levine and GRASP at Pennovation, or GRASP at Perch. And so what I'm going to do is, this is now where we're gonna sort of start our tour. And in fact, those of you who might be interested, you can actually watch this video. I provide the link at the top here. There's actually a sound. I'm keeping the sound off so that I can talk over this. So we're going to start with GRASP at Levine, and this is Levine Hall, which is really at the heart of Penn Engineering. And so here our main space is in Levine 403. And what you're seeing here, this is a newly renovated space. This is the primary area where most of our PhD students sit. So these desks are actually assigned PhD student desk. Here, let me see if I can pause this for a second. So within that area, we have sort of individual offices as well as collaboration spaces, sort of places where people can get together and discuss ideas. We have our experimental bays, and here what you're seeing is at the very, towards the very back, we have Baxter's, we have a robot, we have Sawyer, as well as an AR-10 robot. And then in addition, so we have an interactive portal that connects our GRASP sort of in Levine space with the space that will be at Pennovation, which you'll see later. So here, this is GRASP, this is Levine 457, and this is the space where most of these quad rotor, sort of viral quad rotor videos that you guys see on YouTube has been made. So within this area, we have a nicely instrumented with a motion capture system. And then sort of that big board that this is a high bay area, which makes it suitable for flying swarms. And so we do all kinds of, we also do sort of experiments with walking, climbing robots in there as well. So in addition to experimental and office space, we also have sort of student lounges and meeting rooms because robotics is an interdisciplinary effort. And so we provide, lots of opportunities for people to get together and discuss and exchange ideas. This is Dr. Michael Posa's DARE lab, and this is actually a Cassie bipedal robot. And so his group focuses on developing robust control strategies for walking robots. This is Dr. Cynthia Song's lab. And so in her lab, what she's focusing on is how can you use ideas from origami and folding and be able to come up with ways to design sort of inexpensive, oh no, this is not good. Let me see what happened there. Let me see if I can try to speed this along. And then try to, okay, hold on 1 second. Let me get this back. And then so in Dr. Sun's lab, they focus on how do you design, right, origami robots that can change shape in order to do actuation, locomotion. And let me see, how can I get this thing to play a little faster? Otherwise, we'll just let it catch up. And then sort of the other, so this is all housed on main campus, basically within this GRASP at Levine area. And then in addition to that, I mentioned about this interactive portal. And so a couple years back, we have a new space, and let's see if we can move this a little bit faster along. And let's see, I'm not quite sure why it is that my slider bar is not showing up. So Okay, I'm gonna let this play, and I just and then so basically what happens is that we kind of we were all sort of within this area, and then due to space as we were expanding, we started found there's a new space opening up. What is really neat, this is the Pennovation campus, and the idea here is to provide both a laboratory as well as an incubator location, right? Where a lot of these cool project ideas, we can think about transitioning, right? Sort of some of these research efforts and think about industrial applications. So before actually I go to Pennovation, where you're seeing this is the rehabilitation robotics lab this is Dr. Michelle Johnson's lab. And so they have quite a few humanoid robotics platforms, because they're thinking about sort of applications in medical robots. This is a view of our Pennovation campus. What is really cool about this campus is actually right on the banks of the Schuylkill River. And it actually, backs up right onto the river. And right here, this is Perch. So this is the primary grass lab space on Pennovation campus. And what you're seeing here is a combination, again, of PhD student desks, as well as a sort of large indoor testing area that is fully equipped with motion capture systems. So here we do all kinds of experiments with ground robots, with flying robots, that big mechanism. So this is just giving you a nice view of our mocap. This is actually fully instrumented. It houses Dr. Markiam's MAUD lab, Dr. Dan Kodachek's COD lab, and then Dr. Vijay Kumar's multi-robot systems lab. And so this is all sort of the three groups are housed within this space. And then, we basically are able to use the motion capture system to run experiments with air, ground, robots. There's also, so this structure that you're seeing is a variable truss structure. And basically it's a robot that can change its shape. It can get bigger, it can get smaller. And the idea here is to be able to use it for search and rescue applications. Within that Pennovation building, we also have our in-house fabrication facility. And this is where our laser cutters, our 3D printers, and CNC machines are housed. We have awesome engineers and support personnel that helps us helps us build some of these, the really cool stuff that you're seeing. And then again, students have access to this, to the facilities as well. So, if you are someone who likes to build things yourself, and that's what you're doing for your project, you have access to the facility, to the various pieces of equipment in order to complete your work. This is our outdoor flying area. So in addition to doing experiments indoors, we obviously can take things outdoors. What is nice about this netted area was we are not constrained by airspace restrictions. And in addition to that, the space is also sort of instrumented with motion capture system. So now this is a slightly different part of Pennovation, and what you're seeing, this is my lab. What you're seeing in the back here is our big water tank, which is also the virtual background that I have here. And this is where we are able to create controllable ocean-like flows. And then in addition to those flows, we can put our autonomous boats in there and be able to test and validate our planning strategies and control strategies for single and multi-robot teams. And then, we have quiet space for those, who would rather, find a space that you want to be able to have some quiet area to do some thinking. This is the kitchen and the lounge area, sort of right next to the quiet space. And so since we're expanding, so there's, sort of new space also on the Pennovation that is being, that in theory should be coming online soon. So I'll let you guys, watch that and the rest of that. I'm here, in addition to all the research that we do, we also sort of engaged in a lot of outreach activities. And so this is the Unite sort of student mentorship program, summer mentorship program that is focused on ninth graders in the Philadelphia area. And so for this project, so this is our summer robotics program, they are supposed to be building these little ground robots. Now, I'm put the two videos. So the top video here is the 2019 effort. So you're seeing a lot of the kids being able to, play with the robots outside. For this past summer, we actually, did this in an online version. And so what you're seeing is sort of a fundamentally sort of different experience, because now these are the kits that the students got in their homes. And then instruction and mentoring was basically done completely remotely and online. And what was really cool is the fact that, we were actually, we provide financial support. So in terms of equipment, but also this summer, we help students be able to get online for those of them who may have had difficulties getting internet access. So we also have programs that are targeted to high school teachers. And so this is back in the summer of 2017. I'm going to let this video play for a little bit. And this is just giving you a sense of one of the participants. So she's a math teacher.
Dr. Shea, we're not able to hear audio for your video.
So I'm just going to sort of stop that. So this is actually, I loved her project. I remember her presentation, and it was actually, fantastic. So this is just an example of some of the work that our students are involved in. So a lot of these programs, they're being mentored by, PhD students, postdocs in the lab. And then in addition to this PhD students and the postdocs, these high school teachers and the students also get a chance to talk to GRAS faculty. They also have a GRAS faculty mentor. So just to summarize, so this is our GRAS community. So for students who are actively enrolled in the programs, we have weekly seminar series. We have our GRAS on robotics, which if you guys subscribe to the GRAS YouTube channel, you can actually see recordings of all the past ones that we've started this fall. In addition to that, we have our student, faculty, and industry series, which is sort of more focused, sort of more contained and focused on certain types of applications and projects that students are interested in. So the student, faculty, and industry series is actually a student-run series, so they decide who to invite. We have annual industry days, which gives students opportunities to network with industries and all across the country, all across the world. And then in addition to that, we have various social events. Our alums, they go everywhere. We have these are sort of located in terms of the academic institutions, are places where our recent alums, so this is just within the last 6 months, sort of have gone to after they've graduated from GRASP. A lot of them have started startup companies. So these are the companies that are actually housed within the Pennovation campus. And then there's also other companies that our students go to, right? Sort of these are pretty common robotics companies that we often see their names on. So here's the link for the lab YouTube channel, as well as the lab website. And I see a lot of stuff popping up in the chat channel. So, I'm going to stop my screen sharing for now, and then I'll take questions.
Thank you, Dr. Shea. So I know we've gone over time for this morning session, but I appreciate you all being here. You should now refer to the emails that were sent to you by the department program coordinators. So whichever program you were interested in entering, please refer to that email and you can find the Zoom link where you can join them for the departmental activities. Thank you for joining us and welcome to Penn.